New in VCF Operations 9.1 is real-time metrics. Real-time metrics enables near real-time visibility into select performance-related metrics that can be viewed using interactive charts available in the VCF Operations Workbench. Real-time metrics is part of the VCF management services. As such, this demonstration begins by reviewing the status of the VCF runtime services and the real-time metrics component. From VCF Operations, the user navigates to the Build tab and selects Lifecycle. Here, a summary of the VCF management service components deployed in this VCF instance is displayed. Selecting the VCF services runtime reveals additional details, such as the size of the deployment, large in this example, the assigned IP addresses, and fully qualified domain names, the deployed nodes, and the status of the components. Returning to the Components view and selecting the Real-Time Metrics component displays additional details about that specific service. Here we see the status, the size, and network parameters. In addition, under Action, users are able to scale the real-time metrics, manage log bundles, as well as stop and start the service. With real-time metrics enabled in the VCF instance, the focus now shifts to the categories of metrics for which real-time data can be collected. Once real-time metrics have been enabled, 20-second data collection begins for a subset of the vCenter, ESX, vSAN, and NSX metrics. This default set of metrics is referred to as the Essential category. Essential metrics are enabled by default and cannot be disabled. Users can optionally enable real-time data collection for two additional categories, Standard and esxtop. To do this, the user navigates to the Operate tab, where under Administration, they select Configuration to edit the real-time metrics settings in the VCF Operations policy. Enabling the Standard Metrics category activates 20-second metric collection for an additional subset of vCenter metrics. In this example, we see that real-time metrics for the Standard category has already been enabled. The third category of real-time metrics is specific to the ESX host and is referred to as esxtop. The esxtop category enables 2-second metric collection for select ESX metrics in order to allow the esxtop data to be viewed directly from VCF Operations. Clicking the drop-down and selecting the host system shows that the esxtop category has also been enabled for this VCF instance. An important note to keep in mind when enabling real-time metrics collection for the Standard and esxtop categories is that because of the volume of data generated with these extra categories, the real-time metrics component must first be scaled to large in the VCF services runtime before enabling the Standard and esxtop categories in the VCF Operations policy. Also, it is typically recommended that these optional categories only be enabled during active troubleshooting or issue investigation. It is similar to turning on debug mode to get extra insight when you need it and turning it off when it's no longer required. Next, let's explore how to access real-time metrics in the VCF Operations Workbench. Navigating to the VCF Operations Workbench. The process begins by selecting an inventory object for which real-time metrics is needed. In this example, the management cluster for the VCF instance is used. To access the real-time metrics, navigate to the Real-Time Analysis tab. This tab has 3 sections. The Overview tab shows the history of metrics that have been collected. This view can be adjusted to show statistics anywhere from the last hour up to the last 30 days. In addition, using the drop-down, users can toggle between a host-centric or VM-centric view. Users can also zoom in to sections of the graph to see additional details. In this view, clicking on the data points for CPU usage reveals that a recurring spike in CPU usage is associated with the host ESX-03A. In addition, clicking across the data points confirms that these metrics are being collected at 20-second intervals. Note that the contents shown in the overview graph are based on the inventory object that is selected in the inventory tree. To investigate the high CPU utilization on the host ESX03A in more detail, let's select that specific host in the inventory tree. Here, the CPU utilization is displayed again, but this time only for the selected host. Zooming in on the most recent data, we see that another spike is occurring. Since real-time metrics have been enabled for the esxtop category, the esxtop data for this host can be viewed to see if any additional insight can be gained. Clicking the Select View dropdown, the user selects esxtop. Next, zooming in allows the user to click on the data points. Here we can confirm that the esxtop data is being collected at 2-second intervals. As a high number of metrics is being collected, the overview graphs can become difficult to navigate. To help with navigating large data sets, the Top N tab can be utilized. This tab allows users to quickly filter the real-time data on specific metrics in order to quickly identify the highest resource consumers. In this instance, the filter is specified to look at the CPU utilization and CPU contention metrics for the ESX03A host. Zooming in on the two graphs allows for a closer inspection of the near real-time data. Note that here again, this data is being collected at 20-second intervals. Finally, there is the Custom Query tab. Here you can use the Prometheus query language, or PromQL, to perform custom queries against the real-time metrics stored in VCF operations. Using PromQL, custom views of the real-time data can easily be created. For those who are new to PromQL, a quick query builder tutorial is available to assist in learning how to create PromQL queries. This can act as a powerful learning guide demonstrating exactly how to build custom queries and expressions using PromQL. In this example, we will use the quick query builder to query the CPU usage for the host ESX03A. Another notable feature associated with using PromQL in VCF operations is that the custom queries can be captured and reused in custom dashboards. This bridges the gap for the operations team who prefer Prometheus-style querying by allowing them to pin PromQL expressions right into customized monitoring views via the new PromQL custom widget. Here, we see an example of a custom dashboard created that uses the PromQL widget. This simple dashboard lists the management cluster along with its associated host. Selecting a host from the list then populates the associated graphs. Editing one of the graphs shows that it is based on a PromQL query. This custom dashboard shows an example of how the PromQL feature can be used with the custom dashboard to quickly compare the CPU and memory utilization across hosts in the management cluster. Returning to the Workbench. Another notable improvement is the ability to create and maintain multiple troubleshooting sessions and to make annotations for each independently. When working in the Workbench, a new Notes tab is available. Selecting this tab allows users to capture notes related to troubleshooting efforts. Notes are then readily available to anyone who opens the troubleshooting session. These notes help with documenting incidents, providing audit trails of actions taken, and facilitating collaboration across teams to ensure everyone is up to date with the status of the troubleshooting session. In this example, we will add a note indicating the investigation performed against the recurring CPU spikes on the host ESX03A and highlighting the new custom dashboard that was created. Now, anyone who views this troubleshooting session in the Workbench will be able to view the note and will be aware of the new dashboard that was created. To monitor the ongoing health of the real-time metrics components, the real-time metrics health dashboard is used. This dashboard provides helpful information about the real-time metrics service and its related data store. Specifically, the dashboard provides health information in 4 key areas. First, it identifies any active alerts. Second, it provides an overview of the real-time metrics ingestion. This focuses on how things are scaled and noting if object limit left thresholds have been reached or if there have been any metrics collection failures. Third, an overview of the availability of the real-time metrics service, focusing proactively on issues that could result in a degradation of availability. And finally, an overview of the real-time metrics memory consumption, showing memory utilization and active query rates. This concludes this overview of the VCF Operations Real-Time Metrics feature, introduced with Cloud Foundation 9.1.